Um, I've also shared with you now. This is a John Winfield print called Fort Worth Crossroads. I got a phone call. If you've read your Whistle newsletter, you saw where I got a phone call from a member of the North Texas chapter of the National Railroad Historical Society. It appears that this particular print was commissioned by them for Mr. Winfield to produce, which is another thing, Mr. Corley, that I wanted to talk to you about. We need to give credit there on the copyright to the North Texas chapter of the National Historical Railway Society. And they're perfectly thrilled with us using this print on our website, so we don't have to change anything there. But they did ask that we add them to the copyright holders list there. But Winfield did this print for them for the 2008 national convention that was held here in Dallas-Fort Worth of the NRHS. In talking to their representative, he offered to us a number of prints, of which I have 5 left that are signed and numbered. I do have a number of them left that are not signed and numbered, but the signed and numbered prints are being sold by the division for $35. A portion of that goes back to the NRHS for the $15 of it goes back to the NRHS for the print, and the other 20 goes to the division as a fundraiser. We've got $35 on the signed and numbered ones. We've got $20 on the non-signed and numbered ones. So if you would like to have a Winfield print that is either signed and numbered or just to add to your collection, please email me at director@cowcatcherdivision.org, director@cowcatcherdivision.org. That way we've got everything cataloged numerically. I know when we've got people have responded accordingly. Daryl, you've got room. I see it. I see you looking around to see if you've got room for another one on your wall. Yes, you do. Okay. In fact, I think you've already got it up there, don't you? Yep, that one right there. Yep, that's it. So I want to just keep the records of it as to who sent me notification accordingly, and going for there. So do it by email. We've got 5 left that are signed and numbered, and going from there. AP talk, Mr. Richardson. You want to share anything about the achievement program?
We had no paperwork turned in last month.
Oh, that's horrible.
Yep. Especially with so many guys around here so close.
Yes.
Or already done. True. They just need to turn in the paperwork.
Lori Paletti is gathering paperwork to turn in. Do we need to share information about the email that you got from Frank, Dwayne?
No, we do not.
Okay.
Absolutely not.
All right. That's all I needed to hear. So let's see. I'm trying to think of where else. AP stuff. Mr. Greco, I didn't know that I was holding you up. We will schedule a Zoom call. Tom, what's your schedule availability for Monday through, let's see, Monday, Wednesday, or Thursday of next week?
Well, let me look here, Mike, just a second now.
Tom wants to, is this for prototype, Tom?
That's correct. That's right. This is the Colorado Midland Roundhouse in Colorado Springs. I'm good any day. Well, Monday evening I'm tied up. Tuesday evening I'm tied up, but during the day I'm fine. What's it look like for you?
Dwayne, is there any way you could slip away for a mid-morning or mid-afternoon call?
Probably not. We're in the middle of a migration, so
Are you
every
kind of
yeah.
slammed?
How about
Mike,
Wednesday night?
I'd be willing to be part of that.
Well, I don't know. Bruce, we've got to get you approved by the regional AP guy.
I
Bruce
know.
is
I know.
approved.
He's what?
Bruce
Disapproved?
is approved.
How about Wednesday evening?
Let Bruce, if Bruce jumps in here, Tom, then we could do it mid-morning, which would probably work out. Is that okay with you, Bruce? I know you're an hour behind
Most
us,
days,
but
2 hours. 2 hours.
Say to your 2 hours now. Okay. So if we schedule it for like 11 o'clock, then you could do it at 9 and we'd be okay. Is that good?
Mm-hmm.
Okay. I will send you guys a Zoom meeting invitation for either Monday or Wednesday morning, 11 o'clock our time, Tom, and that would be Bruce's 9 a.m. Is that good for you, Tom?
Sounds great, Mike.
Okay. We'll get you covered, and then Dwayne, we can get your we'll get you all the paperwork turned in and go from there, Dwayne.
Sounds good.
All right. Let's see. Again, I just had a text message on my phone from Ken Kaiser. Please email the and his question was, how do I pay for the picture? And I didn't even mention that. Send a check to my home address, made out to Cowcatcher Division. Okay. Thanks, Ken, for bringing that up. I appreciate it. Make the check out to Cowcatcher Division for either for $35 for the signed and numbered, for $20 for the unsigned and numbered, and then mail it to my address, which is as follows. If you want to write this down, 6245 Bush Buck Run. All that's 3 words, Bush Buck Run. That's Fort Worth, and the zip code is 76179. Sorry, I didn't mention that, Ken. Thanks for catching that for me. Show and tell. Anybody got anything for show and tell? Raise your hand. I'll call on you. We can go from there. Yes, Jeff, tell us more. What do you have?
I have here my favorite tool for sprue cutting.
Okay.
This is it's like a nail clipper, except instead of being curved, it's straight, it's fast, it's clean, and it's cheap.
Okay. And you bought it where?
I bought it at a beauty supply store.
Okay.
Great place to get tools.
Like Sally Beauty Supply?
Yeah, I got it at Ulta, and Ulta, last time I went by, they had put it in a complicated manicure kit, but it's a trim brand, so you should be able to find this online.
Okay.
Trim cuticle clipper 01210.
Okay. And Jeff, let us know how that waterproof. Jeff, let us know how that waterproof mascara is working out for you next meeting. Okay.
All right, I will. I got a pretty good coat of it last night. We were power washing a fence that hadn't been done in years, and I looked like a chimney sweep.
I bet you did. I bet you did. Bruce, you got your hand raised. Are you going to show us garden railroading stuff?
Yes, sir, I am.
I thought you might, since I saw you outside.
I'm sitting. Well, let's see him. I got that covered up. Anyhow, I'm sitting here under the orange tree, and I can flip this around. I've been working today on I lay track in kind of a reverse direction. If you can see over here, I got the track in position held up by little blocks. And then I come in and put the underlayment under it. And then I put the ballast on top of that. Makes it a lot easier to get the grades and angles and stuff that I want. So I've been out here this morning shoveling rock.
I tell you what, brother, I do not envy you that. I mowed the yard and did the weed eating thing for the second time of the season yesterday, and my back was killing me when I got through. There's no telling what you're going to feel like after shoveling rock all morning. So,
well, it's not going to be all morning. It's an hour or two at a time. That's why this has been a 3-year project.
I got you. All right. Sounds good. Anybody else have, thanks for sharing that. Both Jeff and Bruce. Anybody else have anything for show and tell? Raise your hand. Nobody. Well, yours truly has started working on back on the Tyler Depot. And as you can see here, I'm starting to, oh, that's the wrong camera there. That's the one I wanted. I'm starting to get more of the brick walls, the window frames, things like this. These are for doors here that you see that I'm coming in here. I got one window I've still got to put in right down here on this end. But all of this is 3D printed. You can see the roof supports. If you've ever been to the Tyler Depot, just a little bit east of here in Tyler, Texas, where I grew up, that's one of the reasons I'm modeling this. I'm doing this for my prototype modeler. This is another wall that you can see that we've got for, this is the north end wall. They did a little bit of a modification on this. As you can see right here, this particular roof support is trimmed off when they added this door. So they just cut it off. So I modeled that accordingly. You can also notice, and I'm trying to make sure that you can see this a little bit better, the brick that I painted here has got some different coloring and mottling, not modeling, but mottling color on it. And the way that I did that, which comes back in and ties right into the next part of our meeting, is tips and tricks. I did it with a sponge technique. One of the things that I did is I took one of these sponges. You get them, I got them in the craft area at Walmart. They're available there. You can also get them at Hobby Lobby. They come in kind of a net sack, but I take them and then I will put 2 or 3 different colors and shades of paint all in a little area, and then just dab the sponge into that paint and then use that to dab that onto the model. And it allows you to get some different shades, different colors, different textures of the paint in that particular area when you're painting. So it's great for brick. It's great for giving you just subtle coloring hues and changing that on different buildings that you're building. Another little tip and trick that I got the other day, if you've not used this product right here, it's called Never Stall. One of the things that I do with this, a lot of folks put it on the rail. I do not do that. What I use this for is a lubricant at the location where you have an electrical contact on the axle to the motor pickup on the frame. So if you put a drop of this is a conductive lubricant. It conducts electricity. So if you've got that, it will go ahead and let the electricity flow from the location where it's being picked up through that little joint, and it goes there. I just put a little drop of it right there. Mr. Petrarca told me about this. I started using it, and the performance was immediately noticeable for an improvement on locomotives. So I've gone back and started doing that on any kind of a piece of rolling stock, including cabooses that are lit, passenger cars, etc. So that if you want to make sure that you don't have a flicker in lighting and you don't have keep alive in it, then you got that and you go from there. So this product, when I bought it, it was available from Daylight Sales, which is also the location where you get your Division I shirt like I'm wearing with the logo embroidered on it. So go to Daylight Sales and you can, on the internet, I think they both have a .com and a .net. So you can pick up your tubes of Neverstall and go from there. Dwayne, you got a tip and trick for us like you normally do this month?
You can do the exact same thing with wall clipper oil, and it's cheaper.
Yep, you can do it. You can do it with wall clipper oil that you can get at Sally Beauty Supply, and I have used that.
Sally's Walmart even carries it.
Oh, do they? I didn't know that.
I've seen it there in the past. Now,
okay.
If they still have it, I don't know. But yeah, I mean, you can order it off Amazon. It does a lot of the same thing. It really does make a big difference. I know a lot of the guys in Kansas City swear by it. I mean, it's their go-to thing. Yeah. I've been in operating sessions where, an engine will starting and sputter and it just like that. And you pop a little bit on the rail. And I mean, when I say a little bit, I mean like a drop on each rail, and slide the locomotive back and forth, crank him up, runs like a champ. It really is a good product to keep in mind.
I've used that wall clipper oil in commercial applications. Jeff and I, when we're working with Venue Arts and using, trying to make sure that locomotives stay running through a Christmas period and they don't stall out, we'll use wall clipper oil. But like you say, it doesn't take much.
The other thing you got to keep kind of careful of is always clean track. I mean, and it's you start talking track cleaning, it's like talking religion and politics. It always gets dangerous with model railroaders talking about how you go about doing it. But one of the things that I can pass on as a tip, everybody goes and reaches for a bright boy when they think they've got dirty track, and what that ends up doing is it's very abrasive. It ends up putting scratches into the top of your railhead, which then attracts dust and everything else, which then makes the problem worse. If you can, avoid using something as coarse as a bright boy. For luthiers, guys who make guitars and things like that, there is what they call a fret eraser. You can get them from stuartmcdonald.com, stumac.com. They make tools and things for those of us who like tinkering with guitars, and they make these erasers, and they look just like an eraser you used to carry at school, and they come in various grits, and you can get them all the way up to a couple of thousand, and they're great for polishing out railhead.
And what are the costs on that, Dwayne?
I haven't looked in a while because one of those things lasts a long time, and I bought a set of 4 or 5 of them years ago. I want to say they're $7 or $8, maybe something like that.
Okay,
but
Dwayne, are they good for car wheels and locomotive wheels as well?
You can. They're a little harder to get into because it's a little brick type eraser, about yay wide and about an inch tall kind of thing, and then about 3/8 of an inch thick, something like that. But you can get in there with the side of it and clean them off with that if you wanted to.
Okay.
Dwayne, there's also a diamond track cleaner bar that we use at the club that is much, much finer grit than a bright boy.
Yeah.
And, it's as much polish as the rail as anything else.
And that's one of the reasons why I like these fret erasers, and that's their design. Is they're actually there for when you've gone through and you've leveled everything off and you're recrowning the frets, you want to polish all that work out. And that's exactly what this one's for. And you can, like I say, you can get them in various grits. So if you find one that isn't quite as aggressive as you might need it to be, you can buy one a little bit lower. But yeah, I mean, the whole idea is you want something high enough of a grit that you're polishing it, not 80 grit coarse sandpaper and putting big gouges in your railheads.
The last time my friend Pat McCarthy was over here, he showed me a technique on this same genre. He asked me for my whetstone that I use to sharpen my knives. And it's an Arkansas whetstone that is extremely fine. I mean, it's almost smooth. It's an almost smooth rock. And it's meant for honing down a a knife, obviously, and sharpening the knife. Well, he took it and started rubbing it across the rail, and it cleans it right up. And with just a little bit of oil, you clean the stone and keep the stone clean. Just a regular little bit of oil there, and it cleans the stone, and it helps you clean your rail and polish that rail out that way as well. So there's a lot of different things, but I would urge you to get away from using a bright boy if you can at all, and start using something to polish the rail rather than scar and scratch the rail. So
yeah, I just pulled it up on StuMac's website. They're $8.98 a piece. They come in everything from 220 grit all the way up to 8,000 grit, or you can buy a whole set if you really want to get into it.
8,000 grit. Wow. That's pretty amazing.
Yeah, you can put a mirror sheen on it if you wanted to.
Yeah, absolutely. I see Bruce is now doing shameful plugs for Lynchfield Station there. He's got his coffee cup there. He's going to do that. So
I figured that if I brought out my Santa Fe one, I'd get ragged on. So, by some, but not by others.
Hey, just so you know, Gordy's still on here and he's paying attention. Every time you bring up a decoder stuff and all that kind of stuff, he thinks you're getting closer to that volunteer spot for standards on DCC. So I'm just letting you know that. Anybody have any questions on Q&A before we flip over to Clarence? Q&A. Anybody? Nothing. All right.
Hey, Mike, real quick.
Yes, sir. Mossy, go ahead.
Is there a sign-up sheet that is going around for that model build that you guys are talking about?
Well, Mossy, we're trying to keep it local. I mean, I appreciate you wanting to join in from California, but we're talking about the shipping back and forth and handing it off from one person to another. And I asked Dwayne that exact same question, as how far do we reach outside the area to let people participate? So if we can figure out some way with the current situation and experience and trials and tribulations we've had of shipping things back and forth between you and
problems in the post office. What are you talking about?
Oh, I know. I of what do I speak, right?
Yeah. We'd have to overnight it out there to him, then have him overnight it back just to cut down on the shipping.
Yeah, exactly. Yeah. So maybe we can talk about that. Maybe we can do a different project build other than the one we're doing here in the division, and kind of tie that together. But yeah, it sounds great. I'd love for you to participate. I just wish there was if you just lived in Texas or in our division, it'd be home free, man.
You guys can always move here. I wouldn't suggest.
No, and absolutely not. And pay state income tax. Not going there. Okay.
Not unless you want to be broke.
There you go. Or broker. Yeah.
Thank you.
Dr. Tom, I see you've joined us from the great Northwest. Thank you. I'm glad you're here. I would like to have an opportunity to have a little bit of one-on-one time with you a little bit later after the meeting. Would that be possible, Dr. Tom?
Just give me a call.
I will do it. Same phone number you had in West Texas?
Yeah, that's the only thing I didn't change. Well, email didn't change.
Okay. Very good. Very good. Thank you, sir. Appreciate it.
You bet.
Okay. Guys, we are so fortunate to have with us today a gentleman who has spent years and years and years in the mining industry. He's been a consultant on every possible kind of mine you can think of. Every time I discuss things with him and have an opportunity to pick his brain a little bit and ask him questions, it is an entire treasure trove of information. I first got on this particular area of trying to understand what kind of mines that I could have because I model East Texas. So I went to him. I said, "Is there a particular type of mine that was over in East Texas?" He goes, "Oh yeah, iron ore." And I said, "Seriously?" He goes, "Yep." I said, "What would you use the iron ore for?" And one of the things he came back with was that they would grind it up and use it. This particular grade of iron ore, you would grind it up and add it to cattle feed to increase the iron in their feed. I had no clue. I had never even fathomed that as a possibility. So since I've got a big stockyards on my layout, it was a natural fit that I have an iron ore mine that would be transporting iron ore to a feed mill to add that in as an additive to feed. And it
we
just
wonder why
opened up.
steaks are tough.
Yeah, exactly. And that's why your steaks are tough. That's right, Daryl. Now, a lot of us aren't eating steak anymore, but obviously you are. So there you have it. Okay.
And
But
you're getting a smaller steak per pound because it's
there
full
you
of
go.
iron
There you
ore.
go. Because it weighs more. Iron weighs, right?
Yeah.
So so it opened up the door. I mean, I was even talking to him yesterday when we were doing a test run of his connectivity to Zoom, and he was telling me about the fact that certain types of mines have implications in the glass industry. So it's an entirely new area. Not all mines on model railroads need to be coal or silver or gold or diamonds. So without further ado, allow me to introduce Mr. Clarence Zink of Division One. Clarence, take it away.
All right, guys. Well, I don't know if I deserve that glowing review. Like Mike says, I've been in the mining industry for quite a while. I've got a degree in geology from the University of Montana, graduated there in 1972. So that gives you an idea how old I am. I've spent 4 years in the oil field and then got into the mining business as a mine geologist at tungsten mines in Nevada in 1970. When the hell was it? 1977. And been in the mining business ever since. Traveled all over the world. I've been to 46, I think it is, different countries, and been in, like Mike said, virtually every type of mine that there is, surface and underground, anything from coal and diamonds, which are only related because they're both carbon, platinum, palladium, silver, lead, zinc, gold, anything in between. When Mike asked me about doing a follow-up to the first bunch of Mining for Modelers clinics that I put on, which was basically, this is what mines are and smelters and things like that. He says, well, but what happens to the product later? And he gave the example of the iron ore that used to be mined in East Texas, down there around Lone Star, and actually the Texas State Railroad was started as a mining railroad for iron ore that was smelted by the prisoners at the state prison down there. There's a lot of stuff that goes on downstream from the mines, and that's kind of what I'm trying to achieve here today, or show you guys today. So I'm going to start this thing, and I'm going to click the share the screen button. If you have any questions at all, go ahead and shout them out. So here we go. See if I can get this to work right. Okay. Texas Western Model Railroad Club, in conjunction with me, myself, Zink Futures, we're presenting the mine production end products. What is produced? How is it shipped? What is it made into? We're going to talk about the form of the mine's products. What is it that the mines actually do ship out? We'll try to illustrate the methods of the product shipping. We'll talk about what industries the mine products are shipped to, and what the finished products are that are manufactured for consumers. And the consumers can be anywhere from you and I consuming ceramic plates, dinner plates, to a brass foundry, taking in bars of copper that they then alloy into brass, or electronics producers, things like that. We'll look at aluminum, copper, lead and zinc, steel, phosphate, cement, clay, barite, soda ash, borax, and potash. And there's another myriad of things that could be added to this list, but I was trying to limit this to only about 35 to 40 minutes. So we'll keep moving on. We'll start out with downstream aluminum products. Talk about bauxite is the raw material for primary aluminum production. Scrap material, scrap aluminum is what's called secondary aluminum production. It's recycled materials. Basically your soft drink cans, beer cans, aluminum fabrication, waste types of stuff like that. Aluminum just happens to be the most common metal on Earth. It makes up about 8% of the Earth's crust. So it's virtually, literally everywhere. But bauxite, the ore for aluminum, is really only found in tropical or subtropical kind of wet regions. The reserves are most plentiful there in Africa, Oceania, South America. And we used to mine bauxite in the United States, in Oregon, Arkansas, Georgia, and Alabama, but those resources are either depleted or have become uneconomic, and so they had to go elsewhere. I know when I was working for before I got retired, working for the drill bit company, we used to send hundreds of drill bits over across the Pacific Ocean to someplace in Africa. Every year they'd buy about 300 drill bits from us, and they would use it to drill the bauxite, shoot it and dig it up and mine it, and turn it into bauxite ore, and then send it off to aluminum refineries. Aluminum's refined from bauxite by extracting the alumina. You react the bauxite ore that you get out of the ground with hot caustic soda to put the aluminum in solution. They then seed that solution with aluminum hydroxide particles that precipitate larger aluminum hydroxide crystals. That ALOH is aluminum, the chemical formula for aluminum hydroxide. Once you get these aluminum hydroxide crystals, you heat it and wash it, and that converts it into an aluminum oxide, which is ALO2, a powder. Aluminum oxide is extremely hard. It's about if you know anything about a hardness scale, it's about a Mohs 8. It's harder than steel. You can scratch glass with it, and it makes a good abrasive. The aluminum oxide powder is then dissolved in a molten cryolite bath. I'm not sure what the cryolite is, but I believe it's a salt bath. A salt, I believe it's molten salt that the aluminum powder is put into. The salt is kept molten through an electrolysis system. And once the carbon anodes, which are the electrodes basically that are put down into the cryolite bath, once they start working, they drive the oxygen away from the aluminum. It goes into the atmosphere, and you get pure aluminum in the bottom of the vessel, the melt vessel that they do this in. And then they simply pour ingots and bars and cylinders and things like that. They get them all checked, and then they ship them out to whoever needs them, whoever their customers are. Aluminum ingots, bars, and cylinders are shipped to processors and fabricators and manufacturers. They're used for the processors remelt the ingots and bars and things like that into to make castings, to make extrusions, to make forgings, pigments and powder, rod and bar aluminum, and sheet and plate aluminum. The markets for aluminum: aerospace, transportation, automotive, and rail, and other. You know, how many aluminum Bethgun rail cars are out there? Things like that. The sides of automobile carriers are probably aluminum rather than steel. Aluminum is real strong, and it saves weight. It's also sent into the electrical market for wiring and cables and things like that, foil and packaging. Everybody's got a roll of Reynolds wrap and aluminum foil in their pantries, aluminum cans, beers and beverages, things like that. Building and construction type stuff, door frames, things, appliances and electronics, and solar panel nanotechnology. I'm not sure what that is, but it's got to do with solar panels. So they use that aluminum in solar panels. Here's a picture of a fella actually casting the aluminum ingots. They've filled a ladle out of the furnace, and he's got this big old pry bar handle on this ladle, and he's pouring the pure aluminum into those ingot molds. Seems to me that's a hellishly dangerous job because he's pouring it towards himself, but that's the way they do.
To say the same thing, Clarence. Watch out for the splash effect there.
Oh yeah, yeah. And it doesn't look like he's wearing much of anything for protection. Now this photograph and many others where you see this down here in the bottom left-hand corner or right-hand corner. It might be bottom left, upper right, upper left, whatever. They're from the Library of Congress, the Farm Security Administration, Office of War Information. Library of Congress, get on there. It is a monster treasure trove of all kinds of photographs. So he's pouring that into there. And once those solidify and cool down, they whack the back of them with a hammer and an aluminum ingot falls out. And then they stack them up. Those things are all ready for shipment to manufacturers and processors and things like that. Looks like egg crates. And then here's a picture of a aluminum storage yard. This was from Reynolds Metal, I think, in Alabama. They're not quite the same kind of ingots. These are kind of the bigger ingots that we originally saw being poured there. But yeah, this is all during World War II. These photos showing, and so there was huge piles of aluminum being used. And then you got to ship it. And lo and behold, what I've tried to do in most of these different materials is show a scene of rail cars being loaded or carrying something. And here, the aluminum's been cast into cylindrical bars, and they're being ready to be shipped. It looks like there's a loading ramp down there at the end on that boxcar, but those are ready to be shipped out. Aluminum products, upper right-hand corner, we got sheet, rolled aluminum sheet, the aluminum door and frames on the Norris Dam, the TVA project down there in Tennessee. That's the lower left-hand corner. World War II engine blocks in the center here. These are truck blocks being made. I think this was in the Jeep or the Chrysler factory in Detroit. They were casting aluminum engine blocks. Aluminum paint down in the lower right-hand corner. You see a lot of aluminum paint now and then. If any of you guys are into old tank cars, Sinclair Refining painted all their tank cars, their name Sinclair and all the rest of the stuff, in aluminum paint, not silver, aluminum. And then there was also tubing, aluminum tubing, aluminum plate, aluminum wire, et cetera, all kinds of different stuff. Move over into copper. The modern cathode transport and refining is what's going on. If you're driving down Interstate 30 going west between Dallas and Fort Worth, usually on Tuesdays and Thursdays, around 5 o'clock, there'll be a truck headed east, a flatbed truck piled up with pure aluminum cathodes from, I think, the El Paso refinery, headed someplace else. I used to see that quite often, and I still see it every once in a while today. But we'll talk also about early ingot transport and refining in Houghton, Michigan, up there in the upper Michigan Peninsula, where the copper industry really got a kickstart way back when. A little bit about the brass industry. Copper is alloyed with tin to make brass. We'll take a look at some wire mills, Anaconda, Phelps Dodge, and Asarco for electrical stuff. We'll talk about the sheet mills. Again, Anaconda, Phelps, Dodge, and Astarco, the major copper miners and producers in the United States over the ages. What's copper sheet used for? Well, pots and pans, roofing materials. Boy, there's nothing quite like the sight of a brand new copper roof going on, because if they're putting a copper roof on there, I know the mining industry is doing real good. And building rails, handrails in buildings. Did you guys know that copper is an antibacterial and antiviral substance? And there were studies done with COVID-19 that showed that if COVID-19 landed on a copper railing, that it had a lifespan of less than 3 hours. Copper kills COVID-19, believe it or not. Pipe mills, plumbing. Everybody's got copper plumbing in their house. H2SO4, sulfuric acid. That's a byproduct of the copper process, smelting process. It's sent back to the mines to help leach the copper. It's sent to chemical plants, and it's shipped in tank cars. And I've got some photos of that in here also. And usually, often, an in-house vertically integrated company is who produces the copper stuff. Vertically integrated, they've got the copper mine, they've got the copper concentrator, they've got the copper smelter, they've got the copper refinery, they've got the copper product company. So they do everything from dig it out of the earth to selling it to the end user. And transport, we'll talk about transporting solid copper and liquid H2SO4, sulfuric acid. This here is a photograph of what's called matte copper. It comes out of a copper smelter. It is not pure. It's about 90 to 95% pure. It is not used for electrical work at all, but it can be used for other types of copper fabrications. These ingots weigh anywhere from 500 to 1,000 pounds each. They will go to a refinery or an electrowinning place and be turned into purer copper. But this is the direct output of a copper smelter. Here's a photograph of transportation. This is Houghton, Michigan, up there in the Michigan Copper Range, up the UP, Upper Peninsula. They used to ship that stuff by boats, and you can see that they were pulling it probably out of these boxcars and then putting it into the boat. This would have been on Lake Superior, and so they would have taken this boatload of copper to down through the Great Lakes, maybe Milwaukee, Chicago, someplace on a lake, Cleveland, something like that. Turn it into wire or, pots and pans and stuff. I think that's a pretty good picture. I got it off of Shorpy. Nice and clear. Sulfuric acid. This is a photograph here of the tank cars that are stacked up at Kennecott, Utah Copper Company, which is a Rio Tinto subsidiary. It's the mine out there, the mine and processing stuff out there near Salt Lake City. This particular photograph is taken at Garfield, which is at the south end of the Great Salt Lake. If you travel west from Salt Lake City to Nevada on Interstate 80, you'll see this stuff. There's literally hundreds of these white tank cars waiting to be used for sulfuric acid transport. Virtually all of the copper smelters that I've seen, US, Arizona, Utah, Arizona, New Mexico, even the ones down in Mexico, ship sulfuric acid in white tank cars. And sulfuric acid is used in wallboard production. They somehow or another use it with the gypsum and to produce, or maybe they use it with limestone and the sulfuric acid to produce gypsum, but it's used in wallboard production. A lot of it is used in the steel pickling process, which is finishing the steel in a steel mill as it comes off the rolling mills, things like that. As I said earlier, they ship it back to the mines, the larger mines, for use in their leaching and electrowinning processes. So there's a lot of this sulfuric acid traffic that goes back and forth. Here we got some copper from the electrowinning process. What is electrowinning? Electrowinning is when you take a anode made of copper and you have a cathode that attracts copper, and the anode is made of less than pure copper, but the cathode ends up being 99.99 plus copper, as pure as you can get. You submerge these things as plates in a tank of sulfuric acid and run an electric current through it, and the copper atoms migrate from the anodes to the cathodes and deposit on the cathodes as pure copper. All the impurities sink to the bottom of the tank, the silver to gold, any precious metals, lead, zinc, and all that crap goes to the bottom of the tank. That's taken off and refined all by itself. But what we have here is the copper process. These guys up here are hanging the anodes in a rack to submerge into the electrowinning tanks. And then these on the train cars here, I don't know, there's looks like maybe 7 train cars, flat cars, of copper cathodes that have already been plated. These cathodes on the bottom right are headed for the Anaconda Copper Refinery in Great Falls, Montana. And a little bit about lead and zinc smelter shipping. The stuff over here on the left is zinc blocks. They cast these things into 250-pound, maybe 300-pound blocks with a piece of bent rebar in them as a handle and ship them like that. They have to have a crane to lift them, or a couple of big hefty guys, but that's how they ship them out. And then over on the right side, you see lead ingots being loaded into a boxcar. So we got transportation of lead and zinc. Both of these pictures are related to the Eagle Picture mines up in Oklahoma, which have long since closed. Okay. Refinery output then. Up on the top, we've got the copper cakes, which are somewhat less pure copper content than wire bar. And the cakes usually will go to for shipment to non-electrical fabricators, roofing materials, pots and pans, things like that. Stuff that does not conduct electricity. You have to have very, very, very pure copper to conduct electricity. If it has too much impurities in it, it doesn't it presents problems in transmission and overheating of wires and things like that. It's actually kind of a fire hazard. Down on the bottom is what's called a wire bar. They're stacking those up after inspection. This process that I was taking these pictures from, actually each of those wire bars gets stamped with a brand name from the refinery that they're in and a batch number so that they can trace the copper back to exactly when it was melted and poured into bars. And as I said, the wire bars go into electrical stuff. And here we got a whole train load again of wire bars ready for shipment to a wire or cable manufacturer. So these things are just stacked up on there. Away you go, flat car load. Hopefully it'll tie down better. What do we get for consumer products with copper? Well, you get the refrigeration tubing. On the left side here, this guy's doing a QA check and wrapping refrigeration tubing for big freezers and things like that. And then this other guy on the right is inspecting a load of copper sheeting, wound copper sheeting in, of all things, a Texas and Pacific boxcar that I think, according to the number up on the door, might be car number 2090. It's a little bit distinct, but you can definitely see that that's a Texas and Pacific car. Okay, And then electrical wiring down here in the bottom, we got all kinds of spools of wire. And then this fellow over here is looking at bus bars. These particular bus bars are being used in the construction of a set of transformers for a power substation. Again, it's got to be pure copper, because when you're putting 8 million volts through something, you don't want any overheating of anything. So got to be good stuff. Steel products. Hey, does this look familiar? Of course, this guy's making trees. We've all tried to make trees with wire. And, you know, from the 1950s, he's not doing too bad a job. But we're all familiar with the plates and beams and tubular, rebar, etc. production from steel mills, but this is a little bit different. And I'll show you some pictures of some historical steel, wire, and cable companies, and then this guy modeling trees. Here's the Spencer Wire Factory in Massachusetts in 1910. Steel wire, mostly for fencing and other types of stuff, not electrical wire. Looks like a kind of a dim plant. And actually, it looks to me like there must be kerosene lamps maybe hanging over that guy's head and maybe over here and over here. So it's not electrified yet, it doesn't appear, or at least very much. And here's a steel, the Wright Wire Company in Worcester, Massachusetts. And you notice it's got railroad tracks on both the left side and the right side. These are definitely associated with loading and unloading cars. I don't know if this is the main line. The thing that doesn't say anything about it, but Worcester, Massachusetts, there's a big wire plant. And then there's modern wire and cable. These are photographs from the Brookfield Wire Company. They make hose wire, fine wire, wire for mesh, welding wire, and then they've got 2 or 3 other varieties, but I didn't want to squeeze them down. They use different grades of steel for each of these different things. So it's a little bit of a complicated process. Hose wire is extremely fine wire that's been woven. The fine wire may be put into cables. Wire mesh, this is for reinforcing concrete or maybe making what's called a sheep fence. It's going to be a pretty tough, probably mild carbon steel. And then welding wire, there's more than just steel in welding wire. There's a variety of, it's alloyed with a variety of stuff so that it works properly when you're welding. And then you get your steel, your typical loads. Here's a Evraz train car of steel plate. It doesn't look like much on there, but that's steel plate, probably 40, 50 feet long. I think this, I'm not sure where the photograph was taken, but there's also another car, probably Evraz car of steel plate right there on the right-hand side, very far right-hand side. I've seen this sort of stuff go through on the Union Pacific over there in Arlington at the Garrett Yard. Much thicker slabs, only 2 or 3 per flat car, and they were usually shipped on a bulkhead. But this just shows a regular flat deck flat car. Tubulars, pipeline stuff, large diameter, small diameter. You can see that they've got these nested inside each other. I hope they've got them blocked into the tube so that they don't slide out. But you can see when they're shipping this, they've got a whole lot of banding anchoring that stuff down. It's all anchored to that bottom layer of black pipe, and then the middle brown pipe is anchored to the black pipe, and the top is, you know, pretty crazy set of webbing in there. There's at least 2 train cars full of that. Here's another one. This is kind of an oddball one. These are forged steel mill grinding balls. They are a specific grade of steel that is highly abrasion resistant. They ship them to the Newmont Gold Company. They have what they call their Jayhawk terminal along Interstate 80 and the UP tracks in Dunfeet, Nevada. The steel balls are shipped in those covered gondolas back, you see back behind them. Those balls are actually 6-inch diameter balls. They unload them from the gondolas into these bins, and then they load them from the bins into dump trucks and haul them to the mine. At the mine, they put the steel balls into the grinding mills to grind up the gold ore. This facility, the Jayhawk facility, actually has a place there in it to repair both the gondolas and the plastic covers. Once the dump trucks have unloaded a load of new mill balls, and they all start out at either 4 inches or 6 inches, they empty the mills out. Once the mill balls get ground down to a certain size, they're no longer effective. And so they reload those into the dump trucks and take them back to this place, put them in the used mill ball pile, and then ship them back out for scrap metal back to the mill ball manufacturer, who remelts the used balls and casts them and forges them into new mill balls. So it's quite an operation. There's the sign you see along Interstate 80 just outside of Dunphy, Nevada. And you can see behind the sign on the ground are several gondola covers. Maybe these are the ones taken off this row of gondolas, the gray gondolas you see right back there on that close rails, so that they can unload the things or reload them. And then that's how they get the mill balls out of the gondolas. So right there, I've given you guys a real good opportunity for a mini modeling project. And actually, I do have another clinic that's never been presented about this facility. So we can do that sometime in the future. This facility also has fuel storage tanks, lubricant storage areas, grease, and heavy oils. It's got a slaked lime storage area. And then just for interest, there's another facility back to the east, in Carlin, Nevada, I believe it is, that receives cyanide for the gold extraction process. And it ships the cyanide, unloads it from the rail cars in bins, stores them, and loads them onto trucks, and moves the cyanide bins in up to the mines. Phosphate. A little bit about phosphate. There's many places around the world there that phosphorus comes from. Phosphate rock is what is mined. And it's a lot of it, most of it, I should say, is actually turned into fertilizer. And they usually ship it from the mine to a processing plant like this one in the photograph by rail. There's major mine production in Florida, Southeast Idaho, and Southwest Wyoming. This plant is up at Kellogg, Idaho. It's, I believe it's actually been closed for several years. There's also another phosphate refinery, a couple of them actually, down in Southeast Idaho. Once you get down onto the Snake River Plain, out of the mountains that border the state of Wyoming, where the phosphate mines are. They will turn phosphate rock into fertilizer for plants, agricultural purposes. They'll turn it into phosphoric acid for whatever purposes that stuff's used for. Incendiaries, you make matches out of phosphorus, tracer bullets and things like that. Flares, highway flares, road flares. Any question there? No? Okay. And then they transport it as solids, and if it's phosphoric acid in liquids. I would imagine that tank cars transporting phosphoric acid are either rubber lined or glass lined.
Remember, you've never been anywhere.
Are you hungry?
Somebody needs to mute themselves. Okay. Downstream clay products. What are we talking about here? Well, we're talking about bentonite, ball clay, and then stuff for bricks and refractories. Adipolgite is another type of clay. Sepiolite, which is a drilling mud, and how they transport it. With the bentonite, we're talking about basically mining dirt that is used for drilling mud. Yep, that's the major use of bentonite. But there's a lot of bentonite used in food. There's a lot of bentonite used in cosmetics, and there's a huge amount of bentonite used in newspaper and magazine paper coatings of the pages to make them smooth. Here's a shot of
Hey,
drilling.
Clarence,
Yes, sir.
that bentonite, they added that with the dirt and stuff to when they weld the rail together.
Yeah.
They packed that mold up and they added that to the packing to pack the mold up around the rail to keep it from breaking through the rail. Through the mold,
okay.
Through the mold.
Do they use it dry or do they make a thick paste out of it?
It was added dry a long time ago. Now they just ship it in a little case and it's all kind of it's got a little bit of moisture to it already.
Ah, okay. Okay. Well, that's interesting. That's interesting. Okay. Thanks.
It's also, hey, this is Jim. It's also used in the clumping kitty litter.
Okay. And kitty litter, I think, is either attapulgite or sepiolite. So there's, that's good to know.
Yeah, my uncle worked in one of the bentonite mines up in Wyoming. So yeah, when they first started doing that, their business just boomed.
Yeah. Yeah. Okay. Who did he work for up there, Jim?
I want to say American Colloid.
Ah, okay. Okay. I visited their plant back in the 80s.
Yeah, this was the one in Upton, Wyoming.
Yeah. Okay. 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 Another thing that bentonite is used for is agglomerating the concentrate from iron ore into pellets. It helps make the pellets. They mix the iron minerals themselves once they've concentrated the ore with bentonite and a couple of other things and put it into a rotary kiln, and it makes those little balls of iron ore. So there's another use for it. Okay. Well, that's good information, guys. Thanks very much. So here's bentonite clay. Jim, this is from your uncle's or whatever's competitor. This is from the Baroid Company, an old picture taken in the 70s of a ceases to be functional place. But here's basically the process plant for it. Bentonite is used in drilling mud, oil and gas, water well, mineral, seismic drilling, et cetera, along with a lot of other stuff as we just talked about. Wyoming has been and is the major U.S. production area. It has the best quality bentonite in the world that's just the way it is. And these couple of photos are from the former Baroid Company, Clay Spur, Wyoming location. Baroid had the best of the best bentonite. So that's kind of an outside look at it, just pretty much a steel panel building, a bunch of bins and things like that. There's their, kind of the rest of it. Basically what they do is they mine the clay out of the pit, they truck it to the plant, they grind it to a powder, they screen it to size to get out all the impurities and things like that. It's stored in these big bins over here and on the back side. Then it'll be put into 50-pound bags or shipped dry in covered hoppers to wherever it needs to go. I know that when I was in the oil field, I hauled hundreds, if not thousands, of 50-pound bags of bentonite. Good stuff, slippery stuff. The cool thing about bentonite is when you get it wet, it expands tremendously, and it makes a real good, high-quality drilling fluid. Talk about bricks. Here's the Mineral Wells Brickworks in 1920. Railroad boxcars there, most likely Texas and Pacific. Nothing was said about the railroad itself, but this is just a photograph of the brickworks. And it's looking to me like they got a bunch of stacks of bricks right down here ready. The round things with the smokestacks in between them are the brick kilns. And here's the Acme Brick Company in Denton, 1935. The T&P Railroad runs through this top right photo from across the bottom, from right to left, and then from left up through the middle. So you can see that the T&P Railroad they've got the brick ovens to the one side and maybe a storage yard to the other. So they pull the trains right in there and load them up and ship the bricks out. And here's kind of in the lower left-hand side is kind of a close-up of the brick ovens. I don't know if these things are still existing. They might be, because this next photo was 1964, the same place. Compare this photo with this last photo, you can see there's been some changes. It looks like a much larger facility now, and it appears to me that the railroad goes way out into the pasture out here, which is probably where the pit for quarrying the clay is. You know, these facilities through here would be the facility for making the brick, mixing the brick and the clay and the sand and the water and whatever else goes in into proper consistency, putting it in the molds, letting the molds dry out, taking the bricks and letting the bricks dry out before they put them in the kilns, et cetera, et cetera. But looks like a pretty busy place. And you can see looks like they're shipping in box cars. They got a couple of box cars here. So that's what's going on there. Bricks. Talk about potash. Here's a photograph upper right-hand side of an underground potash mine, and you can see that head frame brings the stuff up from underground and dumps it right into a very large bin. This was actually, I think, the Eddy Company down in New Mexico, probably around Carlsbad, New Mexico. Way back when in my career, I had to fix a leak in a 2,500 foot deep shaft wall. And so they put me and my grouting machine and my chemicals on top of the skip that goes up and down the shaft, lowered us to the proper position. We drilled a hole through the wall. We pumped chemical grout in there. It's basically an expanding foam. We pumped it in there until we saw it start coming out the cracks, and pretty quickly it solidified and the leak stopped and they hoisted us up. But we were suspended about 2,000 feet above the bottom of the hole, 500 feet below the surface. That was quite an exciting trip. Potash is actually mined as potassium chloride. It's a salt. Table salt is sodium chloride, NaCl. Potassium chloride is KCl. The mineral is sylvinite, which is different than sylvanite. Sylvanite is a radioactive mineral. But uses for potash are fertilizer, because it adds potassium to the ground. Drilling mud conditioner that helps control swelling clays, so your hole doesn't swell up and collapse on you. Road salt de-icer, table salt substitute. It's used in detergents, laundry detergent, dish detergent, dishwasher powders, things like that. It's kind of generally an orangey pink color. It's mined underground, as shown as right, or by a hot solution that's injected into the ground. The hot solution dissolves the salt. It's brought back to the surface, ran out into ponds, and it cools and evaporates and leaves behind pretty pure potassium chloride. And it's usually shipped in covered hopper unit trains, or it's bagged and shipped in 100-pound, 50-pound and 100-pound bags. If you go to your farm supply store out in your local rural areas, you'll be able to buy 50-pound bags of potassium chloride. And here it is. Terminal, the transport is by bulk unit train to export terminals. We had a picture of the Canpotex covered hopper there. This guy here from Potash Corporation is another Canadian potash company. This is the SSA Marine Portland Bulk Terminal number 5. You have a rail yard on the right full of potash cars, a big old loop, and your unloader is down here. The potash is then unloaded from the rail cars, put into these long sheds, this one or this one, and you can see 2 boats parked here along that canal or riverfront area for loading the stuff into. So you bring it in by rail, you store it in the sheds, you take it out of the sheds and load it into the boats. And inside each of these buildings is what they call a reclaimer, which is basically a conveyor belt type scoop thing that scoops up the potash, puts it onto a conveyor belt, and then runs it out to the boats. And then down here on the lower right is a picture of a core of the potash stuff. Like I said, it's kind of an orangey pink. It's salt. Potash salt, KCl, potassium chloride, tastes a little bit different than sodium chloride, but you get the same effect. Pretty much the same effect on each. Okay. Barite products. What is barite? Barite is the weighting agent for drilling mud, and it's also used in a couple of other things. You use it for drilling muds on high pressure wells. This particular facility is the Baker Hughes facility. I used to work for them, but not at this facility. I was in the drill bit end of it, not the mining end of it. This is out there in the Battle Mountain, Nevada, Argenta, Nevada, Dunphy area. This facility and 2 or 3 other different barite companies are located out there in the Dunphy area. The mines for barite are actually in the Argenta area, but it's overall kind of it's west of Battle Mountain, between Battle Mountain and Winnemucca, over in the area, Dunphy area. Barite was also used to be mined in Arkansas at Magnet Cove by a company called Magnet Cove Barium Company, also known as, back in the day, as Magobar, which I used to work for them too. So, but all in the drilling mud end of it, not in the mining end of it. Barite is also used to form radiation shielding concrete. That's a mouthful, but if you're building a building that has to have has a lot of radiation and you need radiation shielding concrete, you add a bunch of barite to it. It inhibits the passage of those X-rays and gamma rays and alpha particles and all that kind of stuff. It's used as a contrast agent in medical applications. I know I had to have a X-ray one time, and they gave me some barium, kind of like Pepto-Bismol, nasty stuff. But I had to drink it, and once it was in my system for a little bit, they could take an X-ray and see what was going on with it. It's a weighting agent and a filler in rubber and paints and plastics. And it's usually transported in 100-pound bags, which is really not all that big a bag because this stuff is heavy. Or it's shipped in bulk solids. And you can see here, you've got a big old boxcar probably being loaded with bags, and you got several covered hoppers being loaded with bags. If you guys get on Google Earth and Google Earth and go out to the Dunphy, Nevada, tell it to locate there, you'll be able to zoom in on these 2 or 3. I think there's 3 barite processing facilities there, and then you can find the mines down to the south of Interstate 80. Soda ash. Everybody loves soda ash. Sodium carbonate, NaCO3. It's conventionally mined underground using road headers and continuous miners. It's also mined by the solution mining process, where they basically inject hot water into the formation that carries this stuff. It dissolves the sodium carbonate. They bring it to the surface, shoot it out into a pond, let it cool and evaporate, and then get the sodium carbonate out of that. Soda ash is used a lot in glass manufacturing. It's one of the ingredients that you mix with silica sand. It's also a water softening agent. It's a cleaning agent. You'll find soda ash in dish detergents and laundry detergents, things like that. It's used in paper manufacturing. It's you'll probably find it in your pantry because it's used in baking and various foods. It's a weak acid neutralizer if you have to neutralize some acid. Green River, Wyoming is the U.S. soda ash mining center. Soda ash was discovered out there about 1937. They probably ship close to 500,000 tons a day of soda ash out of that area. It's all on the UP. Soda ash trains are generally about 110 cars of these covered gondolas. And it's moved, as I said, by unit train. This photograph here and a video I've got, I took last year coming back from Oregon at the Creston, Wyoming exit on Interstate 80. I knew that a soda ash train was coming because I was headed east from Rock Springs. I passed this train, got to Creston, said, I'm going to catch that son of a gun. And so I pulled off, got down by the tracks, and sure enough, about 15 minutes later, here comes the train. Got these photographs and a video of it. Here's the glass making part of it. It's used in bottles, as you can see up there on the top, and in window glass, plate glass, automotive glass, bulletproof glass, all kinds of things like that. A side note to glass making is tin, because when they make flat glass or float glass, what they do is they pour the liquid molten glass onto a bed of molten tin, and it layers onto that tin as wide and as long as they let it get, and it is absolutely perfectly flat. They take it off the tin and it's thicker than is needed for most applications, but then they roll the glass just like they roll steel. They roll it in a kind of a gooey state into the thickness that they want. But the tin is in huge flat vats that the molten glass is poured on. And actually that's what you're seeing down here in this lower right hand corner, is molten glass being poured onto a bed of tin so that it will be absolutely flat. And glass is basically made up of silica sand, some calcium oxide, some soda ash, and some magnesium. And depending upon what glass you're looking at, armored glass, bulletproof glass, window glass, bottle glass, whatever, different ratios of those minerals, materials, and other stuff are used.
I have a quick question for you.
Go ahead.
In glass production, to come up with different colors of glass, do they not use other mined minerals for that as well?
Yes.
For example, I believe red glass, they put gold in it to get the red color.
I don't know about gold. I think it's cobalt is used to make certain shades of blue. I think certain copper minerals will make shades of green, but yeah, they use something that can withstand 2000 degrees Fahrenheit.
Thank you.
Yep. Any other questions about glass? I don't know everything, but I'll try to answer. Okay, boron, borates, also known as borax. These are usually, there's two ways of doing it, mining it from the ground itself or precipitating it from a brine that is produced from a deep well. You get borax out of it, boric acid. And these things are used in agriculture as fertilizers, flame retardants, and in wood preservatives. It's a micronutrient in fertilizers. It helps plants grow. Boron is used in glass and ceramics. It's used as a metallurgical flux, used in cleaning products, insecticides, and semiconductor production. It's transported as liquids, boric acid and things like that, and solids as the borax itself. U.S. Borax, it's a division of Rio Tinto, has a mine out in Death Valley that evidently supplies 1/3 of the world's borate supply. The borate is the mineral, the actual minerals that they mine, and they get a lot of different materials out of that once they purify the borate that they pull out of the ground. Cement products. How do you make cement? Well, you got to mine a certain grade of limestone, and then you burn that limestone with silica, with iron, with aluminum, and in a kiln to get what's called clinker. And then you grind that clinker with gypsum to get cement, which is a powder. Cement does not have any rock in it. It's a powder. It comes in bags or hopper cars or things like that. It's transported in some cement covered hoppers, usually 2-bay hoppers, because they're kind of short and they have a high tonnage rating, and cement is a heavy, dense material. It's also transported in trucks or in bins and naturally in sacks. You buy Portland cement in sacks at Home Depot or Lowe's. Cement, the powder actually, plus an aggregate, which is sand and gravel, plus water, gives you concrete. And so cement is used in roads, building construction, bridge beams, bridge supports, sewer pipe stuff, water transmission, things like that, and a minor amount of agriculture. Portland cement is actually added to chicken feed to make the eggshells harder so that they don't fracture in transport. I don't know how many times you got to buy a dozen eggs and you get 3 of them that just don't want to break. You got to really whack them on the side of the pan to get them. Well, Farmer Jones has got 1 or 2 chickens that really like their cement. You know, it's put into the chicken feed as a powder, but you know, sometimes some chickens I think probably utilize it better than other chickens. But anyway, those are the general uses of it. If you drive from Arlington or Fort Worth east into Dallas on the north side of Interstate 30, you'll go past, I'm not sure what the name of it is, but it's a huge plant on the north side of Interstate 30 over there in Dallas that makes sewer pipes. They use cement for it. The cement they get is brought in, I'm sure, from the Wholesome cement plant down there around Midlothian.
Clarence, I think that used to be Trinity.
It could have been, yeah. Oh, the cement manufacturing place, Trinity? Okay. Anyway.
Trinity Industries.
Okay, Trinity Industries.
Yeah, big storm sewers and storm drain pipe things. I think that's what that was.
Yeah. And I know that the cement plant out at Midlothian years ago, I believe, was Trinity, but then they got bought by Holcim, Holcim, which is a European country. But anyway, both of those facilities are still there. There's not much limestone quarried for cement manufacturing here in Texas. The limestone is not the right grade, other than out there by Midlothian. There's one quarry there, but those big quarries up by Bridgeport and down by Georgetown are more construction grade limestone rather than cement grade limestone. So there is a difference in limestone. Cement grade limestone has to have a higher calcium carbonate content, and it basically does not need to be as physically strong as aggregate type, construction type limestone. So, okay. Here's a shot of an early continental cement plant. I believe this is someplace in Ohio, I think. And thing I noticed is the Wheeling and Lake Erie gondolas. I don't know if those are drop side bottom dumps or whatever, but it looks like a whole string of gondolas there filled with rock going into this cement manufacturing plant. And it looks like the company headquarters are that building back behind it. And here is the Continental Cement place in Davenport, Iowa, a huge facility. You've got the highway that runs along that far side from the bottom right up into kind of the top left. to the right of the highway up in that upper right-hand corner. I believe that's probably the limestone quarry. And then you've got the rest of the facility down there with all the storage bins to the lower right-hand side, the actual cement manufacturing part kind of up in that upper left-hand side. Big establishment. And then this lower photograph is a photograph of the kiln in the cement plant. These things will be fired. They're angled, they run uphill. They will be loaded with the cement material, the limestone, the other stuff that goes in down in the bottom end, and they will be fired from that end with the heat traveling up and the clinker itself traveling up. Once it gets to the top end of the kiln, it's solidified into this clinker stuff that is then dumped into a bin and ground to a powder. Once it's ground to a powder, it will go into the storage tanks. But okay. And that's pretty much it, guys, on this presentation. And I hope it comes through on the PDF that I'll have posted, because I'm not going to put the raw PowerPoint up there. It's way big. It's about 25 megabytes with the pictures and all. But I'm hoping that these links will come through. If you go to the Aluminum Association link, let's see if that'll work. What are we going to have happen here? Whoa, okay, there you go. You can go to this website, and over here on this side, this is the Aluminum Association website. There's all about bauxite right there. If you click on alumina refining, boom, you get that stuff. All kinds of good stuff in there. You go to primary production, all kinds of good stuff in there also. That's just one of those. Let me go back. And back and ooh, let's see, where was I? Got to go back to the PowerPoint. There we are. That's that. Here's a little thing about, I'm not going to do that one. Potash mining nutrients. There's one here about Florida phosphate mining at 17 minutes long. This one here, Western Potash, talks about their hot mining. We'll start that, see what happens. What do we get here?
We don't see it. We don't see
Clarence, you're going to have to do a separate share if you want to do that.
Okay.
Because all we're seeing right now is the links off of the.
Okay. All right. Well, the links work then. So, but yeah, this will be posted on the Division I website under it's the mining. I think it's Mining 108 clinic. It'll be posted there in the next couple of days. Any questions?
I have a question about smelting.
Yep.
Would a smelting industry or a smelting facility handle more than one type of mineral? For example, gold and silver and some other minerals at the same facility, or would they be specifically for each mineral?
Usually what happens is when you mine a metal, I'll put it that way, your primary metal is copper, you're going to get a whole bunch of byproducts with it. In the concentration process where you take the ore, you grind it, you separate out the value versus what they call the value minerals versus the gangue minerals. The value minerals will have, in a copper mine, they'll be predominantly copper, but you'll get a little bit of gold, you get a little bit of silver, you get a little bit of lead, you'll get a little bit of other stuff. That material as a concentrate goes into the smelter, and most of the copper smelters will produce what I was showing as matte, which has got a little bit of everything in it. It's not pure copper. It's about 90% pure. It'll have the gold, to have the silver, and the other stuff in it. From the smelter, it then goes to the refinery, which is either an electrowinning process that I described with the tank houses and the anodes and the cathodes, or it may be a pyrometallurgy, a fire type refinery, where they manipulate the temperature of the melt to separate the gold and the silver and the copper from each other. In any case, the product out of the smelters is never really very pure.
Okay.
It's always sent to a refinery. At the refinery, like if it's an electrowinning refinery, as I said, they do the anode and cathode thing. They pass it. They electrify the cathode or the anode side. They put the anodes parallel to the cathodes in a bath of sulfuric acid, weak sulfuric acid. Put incredible amounts of amperage through this solution to migrate the atoms from the anode to the cathode. The copper will plate out on the cathode, and the gold, silver, lead, zinc, and other stuff will fall to the bottom as a sludge. They can then take that sludge and treat it to get the pure gold, the pure silver, and other things out of it. So there's a whole different set of processes that go into making a pure metal. But a smelter generally will give a product that is a mix of metals with one metal predominant, depending upon what ore you mine.
Okay. Thank you.
Yep. Anything else?
Well, Clarence, thank you so much for your presentation. It was very, very interesting. You did a great job. We really appreciate you putting that together. That was in depth, and it showed a lot of work on your part. So we really appreciate that.
Well, thank you.
You're going to be getting information to our web team.
Yep.
And they'll be posting that onto the website.
Yep.
So that Mr. Richardson can count this towards your author points.
Okay.
And you'll be able to get further along on your AP stuff for authors. So we really appreciate that. And yes,
hey, Mike, can I toss one in here real quick?
Sure.
Clarence, and this goes for anybody who's putting a PowerPoint together. Clarence, if you go out and look at your PowerPoint slide deck and click on any picture, up at the very top, the picture toolbar will come up there in the ribbon. If you click on that, there is an option in there that says compress images. If you'll click on compress images, it defaults out to do only that one image, but you can tick a box and it will compress every image in there. You won't see any difference in the image when you're looking at it, but you can reduce that image down, the DPI count of the picture. It won't impact the way the presentation looks. It'll still print off real nice, but it can take a, I've literally seen presentations that because of the pictures are like 20 and 30 meg, get reduced down to a few hundred KB.
Oh, okay.
So if you go through through that and do that, it might shrink the size of your slide deck out enough that it can be emailed out if you wanted to.
How do you do that?
Just go back in like you're going to edit your picture or edit your deck. Click on any of the picture, and then up at the very top, right up above the main ribbon, there will be one that says something about picture toolbar or something like that.
Yeah.
If you click on that, a little bit left of center, there's an option in there that says compress images.
Compress pictures.
Yep, that's the one.
Oh, okay.
So if you click on that one, click the box to say apply it to all the images, and then pick a lower DPI setting. Click on that, click OK, and it'll reduce it all down, save it, and you'll usually see a pretty significant drop in file size.
Okay, I'll try that. Okay. All right. Any other questions? If anybody is interested in getting a copy of all the materials that I gathered for this, it'll fill a CD. Send me an email with your address, and I'll burn you a CD and send it to you. Or I might be able to load it into my Zoom, not my Zoom box, my Dropbox, and give you access to it.
That's very nice. Thanks, Clarence. We appreciate that.
Okay.
So it's 12 o'clock, 12:01. we're going to wrap up here. Just one more thing. Yesterday and the day before and the day before that, I have noticed a number of BNSF trains on the Choctaw sub of the UP going north and south from Fort Worth into Oklahoma. I am trying to figure out why I'm seeing so many BNSF trains on the UP run over there. Anybody have any ideas or track work going on the BNSF track or anything? Has anybody heard?
There's track work going on in through Carrollton, where I live. They replaced a whole bunch of ties, and they had the geometry car and the tamper and all that stuff come through the last 2 or 3 days. So that might be why they're rerouting that traffic.
Gotcha. Okay. That's interesting information, because and I've also noticed that UP has started running longer trains with helper units in the middle of the train. Yesterday I saw one that had, and I mean, I watch trains all the time, like all you guys do. Okay. Typically you'll see 3-4 units on the front end, if that many, and a helper unit or 2 on the rear. But UP has started putting units, and yesterday I saw 4 units in the middle of one train and 5 in another in the middle of the train. That, to me, that was an awful lot of power in the middle of the train to go with whatever was on the head end. So I just seeing a change there. Typically they didn't run them that way. It was normally stuff on the rear end, but they've started running, and these particular trains did not have anything on the rear end. So
I've seen a couple of those also, Mike. I saw one the other day that had 3 on the front, 3 in the middle, and 1 pushing.
Wow. Okay.
Just probably a week ago, maybe.
Yeah. Just a difference in configuration. Terry, you got any input on that?
A lot of it could be power move.
Yep.
Yeah, that's true. Yeah. Power shift. Yeah.
What kind of trains were they?
I've been and that's another thing. I've been seeing lots and lots and lots of hoppers being moved on both the BNSF and the UP. And then yesterday, the train that I saw headed north, it was all hoppers in front of the helper units in the middle, and all tank cars save 1 behind the locomotive, which is regulation, but all tank cars on the rear end of the train. So I'm thinking they just combined 2 trains for the movement, but then went on, but who knows?
Yeah, that's probably what's happening. 2 different destinations for the same train. Why not run them that way? I know that in Australia, in the coal mine area, they will run really long trains with helper units in the middle, but once you get to the coal terminal, that train splits and goes through 2 different rotary dumpers.
Gotcha.
Once it goes through the rotary dumpers, it combines back together again and goes back to the mine.
Gotcha. One other thing, I just saw somebody else jump in here. Want to welcome Larry Smith, the assistant AP manager for the NMRA, who's joined us from over in Birmingham, Alabama. Welcome, Larry. Glad you joined us, even though we're fixing to adjourn. Wished you'd have gotten here a little bit earlier, but want to welcome you to the meeting nonetheless. So you can say hi, Larry.
We just had basically
that was it. I just heard we just had basically, Larry. That was it. Must be having technical difficulties. So we had another call I had the other day with a guy over in Mississippi, and he was having some really difficult times with his internet over there. I think Dwayne described it as where Gerald Mabry is now back from Kuwait. He looked him up on Google Earth, and it said that somewhere out in Egypt was 12 miles, and Gerald's house was another 1,200 miles beyond that. So if you understand what I'm getting at, guys.
Mike, can you hear me now?
Now we can. Yeah, Larry.
Okay, my mic was out of place. Basically, this morning, what we had was my wife went to turn on a switch in our bathroom, and when she did, sparks came out of it and everything. So there's been an electrician here this morning replacing things.
Oh, well, at least we didn't catch fire and burn the house down.
That's true too, especially when we have aluminum wiring.
Yep. Well, we just learned where all that aluminum comes from. And if you log back into our YouTube channel, Mr. Cranda is going to have this whole session recorded and processed and posted back to our YouTube channel for you to be able to go back in and watch it at your leisure. So go back in, log in, look at cowcatcherdivision.org on the web, and you'll be able to see all of the past clinics we've had. But we're certainly glad that you're here. We had Gordy on a little while ago. He joined us. He had to leave and said thanks for the meeting. But Annabelle was getting ready for dinner and he had to go fix dinner. So it's been a star-packed session today with people from high ranking all through the organization. Thank you for joining us, Larry. Glad to hear. By the way, I'll give you the podium here just for a minute. You have anything in the AP program you want to bring up? We've got Dwayne Richardson is on here with us as our regional AP guy. And so if you want to say anything or share anything about the AP program, Larry.
No, everything's going fairly smooth with it. There's been no complaints. There's been a few of us that have been trying to get some things changed, especially with that ruling on the using the window castings and costing yourself 5 points on scratch building.
Okay.
And
that's a good thing, I would think.
Yeah. Well,
yeah, I'd love to see that go.
So would I. And basically, my theory on it, and maybe eventually we'll be able to get Frank to change his mind on it, is that I think, yes, if you use a casting, you should be penalized, but I think it should be based upon the number that you use versus the number of points that you scratch built. In other words,
some sort of a ratio in there.
Yeah, some sort of a ratio than just a flat out 5 point deduction automatically. So it's that's one that there's some things that have gotten into the AP program really that shouldn't be. And there's been, like an example that I gave Frank was, okay, I've got a cold tipple I built, 1,400 parts. I used 7 windows. I would have lost 5 points. Under what I'm proposing is I might have lost 2. You still should be penalized for it, but you shouldn't be penalized that harsh.
Yeah, I see what you're talking about, Larry. And by the way, just since we've got you here to bend your ear just a second, I know that there's a number of people, and in fact, last month we had a clinic on dead rail.
Mm-hmm.
And that's a progressing angle of our hobby, but because of the way that some of the rules are written for judging on certain aspects of it, it requires somebody to wire something. If they're using dead rail, they're automatically knocked out if they're trying to get civil or part of the electrical. So just thought I'd throw that out there if it might be something worth looking at and being addressed if it's not already.
I don't think it has been addressed yet. It took them a little while to finally figure out that a lot of the things that they've got in there for DCC, and because everything up until DCC really started to come in was geared more towards DC.
Sure.
And finally, somebody says, duh, the same requirements we've got for DC also apply for DCC.
Right, right.
So it's just going to be a question of time if, as we get into new areas, and then it has to be drawn up, approved, and then submitted to the board, and for their approval to make the changes in AP. So it's not a simple process.
Sure, sure. All right. Anybody have any quick questions they want to throw at Larry before we adjourn?
Hey, Larry, this is Dwayne. I've got one for you.
Yeah.
Turnouts. If you're laying turnouts for civil, I have talked with Frank about it in the past, and Frank said at the time that he would consider a Y as a different piece of track work. And I argued at the time, the reason for that is both rails diverge. So the frog geometry is completely different. Your stock rails are completely different. And I see now on the website that it's all lumped back together again. I would like to pitch that a curved turnout and a Y is not a separate turnout, or it should be a separate from just being all lumped together as a turnout in general. A gauge separation turnout is currently listed separately, and all that is a turnout with an extra stock rail thrown up one side. So if we've got that one separated, why not make the other ones separate too? Because they are completely different and harder to lay.
Well, let me give you an answer that a prototype, a real railroader told me. The name of a Y turnout, okay? It's called an equilateral turnout. And if we put it into the as a separate turnout, yeah, let's put it in there as an equilateral turnout. Put it as a classification, not a Y.
No, that's fine. Yeah, whatever we name it, we just need to make it to where people can understand it in layman's terms too, right?
Right. Yeah. In other words, what you do is you put it in there as an equilateral turnout, and then you put parentheses of Y.
Yeah,
absolutely.
But it should be a completely different turnout than your standard turnout, or because it is different.
And that same thing goes for a curved turnout as well.
Exactly.
Now, I've got something else that I'll throw at you, Larry. There's a guy on this call right now, or in this Zoom meeting, that actually laid a turnout with a crossing through the turnout. You talking about total idiocy, but I'm not going to say that to Mossy's face. But anyway, all right. Yes. So just out of curiosity, you've got a crossing and a turnout. Would he get double credit for that?
You should judge each one of them separately.
That's what I'm saying.
Yeah. But if it goes through the frog, you really,
it does. It does. Absolutely, it does. Mossy, do you have that in front of you by chance?
No, I don't. I'm up in the.
You're upstairs. Yeah, I can see that.
Upstairs. I'm not in the layout room right now.
But anybody that would do something like that, I've got to question sanity. So,
so do I.
Mike, I do have a picture of it on my phone I can show real quick if you want me to.
Yeah, and Bruce, I see your hand. I'm not going to forget you over there.
Well, what he needs to do, really, if he wants to go for it, is go with a dual gauge crossing.
Oh, there you go. Yeah, do it there. Look at this.
Can you see the turnout there?
Yeah.
And that goes to a bridge that forms a functioning Y as well for turning locomotives and trains. But that's it.
Nah, it needs to be dual gauge.
Well, I can do that.
Shouldn't we have a gauge separation in there too?
Yeah.
Can I get all three of them signed off in one piece if I put another length of track on there? a dual gauge separation turnout with a crossing in the middle?
Yes.
Sign that off in one shot.
You do, but your certificate comes with a big straight jacket drawn on it. Yeah. And a curve.
Yeah.
Well, that is a curved turnout, by the way.
Oh, geez.
Oh,
and as long as I can wear the straight jacket, I'll gladly wear it.
There you go.
There you go. Bruce, what you got?
I was just going to suggest that the San Diego director, Pete Steinmetz, would be a really good person to be involved with anything that relates to power on board and electrical and civil.
Yeah, I agree. So, yeah, Larry, if you need,
as long as we're volunteering people for positions.
Yep. Yeah, that's what happens when you don't attend the meeting. You get volunteered, right?
But he's operating at the Scottsdale Club today.
Yeah, he told me he was going to be doing that. Larry, if you want his contact information, he's rapidly becoming a very high profile person in that power on board or dead rail community. So
okay,
I can let you guys talk and go from there if you're interested in tapping into his knowledge base.
All right, I'll get back with you on separately, Mike.
That's fine.
By the way, I don't know, did Gordy know what the vote count was? Has he been informed
I
of
believe
that?
it's been shared with him, but it hasn't been shared publicly.
Okay, because I know I talked to Rick Coble last night.
Yep.
And he said that John Stevens eventually would make it public, but he didn't know at the time.
Yeah. So I'm not sure exactly when that's going to be released, but I think that information is out there. So
well, if I find out before you do, I'll send it to you.
Okay, very good. Well, guys, 12:18. We normally try to wrap up between 12 and 12:30. It's been a great meeting. Like I said, we've had some really nice participation. We had a lot of good folks joining in here. Mike Ross, what was our total head count? 49 today, something like that? Unmute yourself there, Mikey. There you go.
47 distinct names. There may be a few duplicates on my list, but that's pretty good.
Did that include Mr. Smith that just joined us?
Every name I can find there. Yes, sir.
Awesome. Close to 50 people on our Zoom call. That's fantastic. We've got some of our normal guys that aren't here today, but it's great to have everybody join us in here, and we're just tickled to death that we're getting this kind of participation. Again, next month, we're going to resume face-to-face meetings, but we will again continue to broadcast on Zoom. So there will be a Mike, Stephen, I see you. Hang on just a minute. So we will send out the Zoom meeting invitation for those that want to join us that way. And we'll be meeting at the Texas Western at 10 o'clock. So just realize that those who choose to go the Zoom route you got to furnish your own donuts and coffee. That won't be the division doing that for you. Stephen, what do you got?
We're going to do the flat car thing, in May?
No, sir. That if you look at the website, it's got our meeting agendas on there and our schedule. We're going to be doing, as we talked previously, we're going to be talking about giving your railroad a purpose in May. Then in June, we're going to have our hot dog cookout. We will pick up the flat car clinic in July. And the reason I pushed it back to July was to give everybody a little bit further worth of COVID vaccination treatments and immunities, to let the numbers drop a little bit further, to make everybody feel a little bit more comfortable in getting together, all of that kind of stuff. So we are going to have another 30 days from today, see if those numbers drop. And I will say this as a caveat: if we see a spike in the numbers and a new wave coming through, I do reserve the right to continue moving back to where we are right here on Zoom as a precaution. The last thing we want to do is to put people in peril on being infected with anything to do with this virus over a hobby. So hopefully you guys appreciate that position. I'm trying to balance everything out on the scales of participation and with caution. So that being said, that's where we are. And I hope you guys agree with it. And I hope you guys approve of where I'm going with that. So anybody else have anything before we say so long from this meeting? Anybody? All right. Guys, thank you again for your participation. Thanks for being here. Hope you had a great meeting. We'll see you soon. Take care. See you later, guys.
Take care.
Bye.
Bye.
Take care, all.